Hey, here we are at the top of the hour. Good afternoon to everyone who may or may not have joined just yet. We're going to give it obviously a minute or two for everyone to continue to join. We have some pretty solid content with some really solid presenters, and part of the conversation that started back in Q4 and Q3 of last year was when containers really jumped to the forefront. We're kind of looking at this decade as containers are going to have the same type of impact that VMware had in the decade of 2000s. So we're just going to give it a minute or two for other people to join and then get right started up. And we really never realized how long a minute of dead air really sounds like. Anyways, we got 3:01 on my clock, so I'm just going to jump in and introduce some of our speakers. We have, as you see on the screen, Randy Arseneau from IBM. Randy's one of the subject matter experts here at IBM, and Dr. Frank Lee, who really is one of the stellar gentlemen on the technical side of things. So we have honored to have them as part of our panelists. And starting us off, I want to thank the folks at Tectrade. Tectrade has been a partner I've known about for roughly 10 years. And a recent addition to their team is a guy named Jason Normanton. And Jason is the head of Tectrade's cloud organization. And the beauty of what Tectrade brings to the table from an IBM perspective is they have a really robust and mature Red Hat presence. And we all know that Red Hat is the industry leader in containers, and we'll get to some of that later in the content. But today's webinar is being hosted as a partnership with Tectrade and IBM. You may notice that Jason's not from Brooklyn. So you may wind up picking up a slight accent. He's actually across the pond and joining us from the UK. So Jason, the floor is yours.
Thank you, John. Randy, could you take me to the first slide? Thank you. So yeah, this wouldn't be a presentation within the 21st century without having the ubiquitous cloud computing slide. So here we go. But the real point that I wanted to point out to you is we all know that the benefits of cloud. This falls definitely within what we call as platform as a service. So providing the entire environment is what we're going to speak to you about. And we do that to try and avoid some of the pitfalls and some of the compliance issues that can stand around that. Next slide, please, Randy. So what is the value proposition of containers? And it kind of came as a coming together of four great elements. I'll talk you through the left-hand side first. So the first thing that really allowed small composable pieces of architecture was an architecture pattern within development called microservices. So it's taking the huge big monolith on the top left-hand side there, the application that we all know that might access your SAP environment or might do some business intelligence or one of those beefy business apps that has lots of functions, and really breaking that down into small functional parts to really increase development times, make a more flexible type of architecture, and rather than having to scale out and up to make a larger instance as the load increases, with a microservices type architecture, you just increase the number of containers presenting that tier, and that way your architecture grows with you. When you couple that with infrastructure on demand and deployment as code capabilities, that gives you a really strong and powerful story within the hosting world around applications as code and declarative deployment of applications. If you could take me to the next one, please, Randy. And what is a container? Well, basically it's a way of accessing a host through a Docker daemon that provides all of the CPU and all of the resources that the container needs. And it's easy to deploy because we have things like source code repository and registries where we hold those images that we create. And it literally is that the command to start a Docker is run, and then the container name and enter. And it's literally that easy to start up the container. Next one, please, Randy. However, running the container is only the very start of that story. There's a whole host of ecosystem components out there, and you can see Red Hat OpenShift is listed within the paths supporting Docker. But really what it is it's taking all of these individual features, extending the core functionality of Docker, and integrating a solution that you can take to production. Docker on its own is not production ready as a deployment and hosting solution if the application needs to do anything with any kind of clever. But also trying to select all of those different components. And if you could go to the next slide, please, Randy. Just to be able to deliver those microservice containers, which you can see in the middle band of the diagram, you need all of the elements that are around the side. So you need service routing, service discovery that says which container is where and on which host and which IP address and what service it's delivering. And it's knitting all of these additional components into the stack that is really where a lot of organizations start to fail, or it takes them a long time to select the right components. If you could press again, please, Randy. So here at Tectrade and CSI Group, we really looked long and hard at the container market, and we took all of the various elements into consideration. And the decision that we made and that we came out of the other side was we would let a distributor actually wrap all of those components together for us, and we would get at least 90% of all of the functionality that we needed through that core package. So when something changes, it's tested by Red Hat before it goes into their OpenShift package. We know that it's going to work whenever we upgrade that package because it's all been tested together. If we could move on to the next one, please. And that really brings us to what should be your major thoughts around containerization. It's more to do with the application migration. Whether you rehost, whether you refactor, whether you re-architect, or you rebuild, the platform should be capable of supporting you through each one of those stages to get to that microservice nirvana. If we can go to the next slide, please. And we understand within any organization that that's going to be an iterative process potentially, especially if it's a very complex app that you're transforming. So there are some key steps there that as you move through. So from a data services based architecture to a service integration architecture, you might have a coarse-grained services architecture then before finally moving through to microservices. And from the third pillar onwards within those architecture designs, containers are there to support you. It's just as you move further to the right-hand side, you get more granularity and control over the solution. So sorry, final slide, please. Well, there may be one after this as well. So that's the power of the application architecture and the infrastructure. And that then enables the people and the culture to develop and to adopt agile methodologies where you're not trying to create the full software product within the first release. You get quickly to market with a product that's viable, and then you add additional functionality onto that, which you deploy via microservices. And if anybody uses a fairly heavy-duty mobile app, that will definitely be the architecture that's following, where you get new release of functionality upon functionality over a fairly short period of time, which leads you to a culture of open source software, where you can build the applications that you need with the right components, and that DevOps mindset of continual deployment and continual creation. Next slide, please, Randy. So our goal here at Tectrade is to make you or allow you to sleep easily at night and not sit there worrying about the infrastructure. And if I could have one more click, please. With a proper architecture and tool set in place, your biggest issue should be with the application itself, the expertise that you bring to the table. You've designed that, you're working on that. You shouldn't need to worry about the underlying infrastructure. And that's where Tectrade, with their partnership with IBM and Red Hat, really feel that we can help you out. And that, for me, thank you very much. If you could click one more, Randy, I think that's my final slide.
All right. Thanks very much, Jason. Great,
Yes.
great intro. So, what I'd like to do is, so Jason gave us a good, fairly deep technology overview on containers. So just to reiterate, the simplest way to think about containers is they're like VMs in the sense that they are abstractions, but they do the abstraction at a more granular level. So where in a VM environment, you've got a full replica of a guest OS that's being hosted by a hypervisor, whereas in a container environment, you've got more of the code abstracted and less of the infrastructure abstracted. So we're going to spend most of the remainder of the session talking about specifically Red Hat OpenShift Container Platform, which is kind of the de facto standard or becoming the de facto standard in the enterprise for container orchestration. And we'll also touch on some of the challenges and issues and best practices around architecting solutions for containerized and microservices environments. But I'm going to start off at a fairly high level. And
hey, Randy, just
yes.
for a quick introduction from a housekeeping perspective, my apologies for the interruption. But anybody who has questions, please place them in the chat, and we'll be addressing that at the end of the webinar. I know that we have a couple that have come in already, but just from a housekeeping perspective, just address your questions in the chat window, and we'll deal with those at the end of the webinar. And want to just also thank Jason real quick. And you can see why Tectrade is IBM and IBM's mind one of the leaders in the clubhouse as far as the partners are concerned. So thanks, Jason, and Randy. Take it home.
Great. Thanks, John. But before we get too deep into the inner workings and machinations of containers, I want to use kind of a simple analogy. I do a lot of presentations like this, and a lot of our clients worldwide are just beginning their containerization journey, so they're still figuring out how it fits in the enterprise and how they can apply containerization technology. So there's kind of a simple analogy floating around that I've adapted a little bit for the purposes of this discussion. And it is based on pets, cattle, chickens, bugs, and snowflakes. So bear with me for a second. I'll take you through these and I'll explain what this means. And hopefully it'll give you a little better understanding at a more kind of a visceral level what these things actually mean. So let's start with pets. Many of us have pets. Probably a lot of people on the call have pets. Pets are individual. They're members of the family. They have personalities. We care for them very closely, pay very close attention to them. You know, they live a fairly long lifespan. You know, they can consume a lot of your time depending on how many you have and what kind of a pet you have, whether you have a dog or a cat or something more exotic. They're pretty easy to take care of until you get too many of them, and then it becomes a bit of a challenge. And again, as you add more, the investment of time and energy required to care for them can become pretty intense and pretty onerous. So think of pets as an analog for bare metal servers. So the bare metal servers that are sitting in your data center fit this category. They're kind of very labor intensive, they're individualized, and they require a lot of your attention and effort. So now let's think about cattle. Typically, cattle exist in a herd. There's lots of them. They generally don't have names, although they may in some cases, depending on how many you have and how emotionally attached to them you are. If one of them gets sick or has a problem, you know, it ends up as dinner in most cases, or not, depending on the condition. You may or may not then replace it, depending on your production cycle and your business model. The life expectancy is shorter than a pet, typically. They also roam around in large spaces, individually, but in large spaces, and you typically monitor them as a group. So you don't always keep track of each individual head of cattle. You generally monitor the herd at kind of a macro level. So think of cattle as an analog for VMs. Sometimes they're sitting in your data center. Sometimes they're sitting on one or more public clouds. So the next one, and this is where we get into the good stuff. So chickens. Chickens are much more efficient than cattle. You can keep a whole bunch more of them in the same or smaller space. They breed and reproduce much faster and more consistently. They have a shorter life expectancy than cattle. If you need to increase production, you can do so incrementally by simply hatching more chickens. So you can chickens scale very effectively. They also require fewer resources and in more granular units of allocation. So you don't have to go buy 50 metric tons of hay or feed. You can buy very small quantities and scale it incrementally. So chickens in the animal kingdom are the best analog for containers because that is the container model. Now, to kind of cycle back to something John said as well, and one of the themes of his discussion was really around microservices. So microservices are kind of like insects in the sense that they typically have a very short lifespan, sometimes only a few hours, By the way, this was the least creepy bug picture I could find. So hopefully you appreciate that I didn't get anything really nasty. They're functionally limited typically. They're sometimes necessary, sometimes they're annoying. You sort of have to have them, but they can be a bit of a pain. But they are lower level and very important parts of a broader ecosystem and food chain. You know, certain animals eat bugs, other animals eat those animals, etc. They pollinate plants, so they do serve a very valuable purpose. So insects are kind of serverless apps or functions as a service. So these are very small, you know, pieces of code or fragments of code that serve very specific purposes. So the last one we'll talk about, and this is kind of like what we want to try to avoid, are snowflakes. They're individually unique by definition. It's impossible to reproduce or replicate them. They're typically kind of fleeting, fairly ephemeral. The more you have, the more difficult they become to shovel and manage. And they're very delicate and they're very susceptible to environmental disruptions. So think of snowflakes as bespoke apps or servers which are highly customized, hand-coded, you know, hand-fed, and require tons of maintenance and are very difficult. This is the old world. This is what we want to try to get away from with containers. So going back to our architectural metaphor for containers, think of containers as chickens in that model, and think of VMs as cattle. Just kind of help you get your mind around the difference. So again, to build on what Jason said earlier, why are containers so important? So we do lots of surveys of global companies. We have obviously thousands of global 1,000 clients across the spectrum of industries around the world, and we survey them and gather data from them on a regular basis to understand where their thought process is, where they're going, where they're investing. Security solutions are always top of mind, but automated deployment and management of IT services, tools to accelerate dev, test, and production, and support for public cloud and on-prem environments are right at the top of the list for things that virtually every organization is thinking about, investing in, and planning for. Now, if you look at that from the perspective of what platforms are being most widely adopted, Docker and Kubernetes in particular are leading the charge and have been for quite some time, actually. They also, not coincidentally, formed the basis for the Red Hat OpenShift container platform, which is built on hardened distributions of Docker and Kubernetes, although it also supports other container frameworks, which I'll talk about in a second. So the message here is that containerization is growing very quickly. It's being adopted very widely. There are lots of open source projects floating around. You'll see some of them listed here, which have had varying degrees of success and adoption within the enterprise. If you want to implement the lowest risk, most widely adopted, you know, most robustly supported platform, OpenShift Container Platform is a great choice. It has been chosen by, you know, many of the Fortune 1000. It's reliable, it's stable, it's fully supported. It's got the full weight of IBM and Red Hat behind it. So it's a pretty safe bet. So OCP, you'll often hear OpenShift Container Platform referred to as OCP. It has really everything you need to achieve that architectural nirvana and that end state that Jason spoke about earlier. Enterprise-grade Linux operating system that underpins it all, full container runtime, full networking, monitoring and management, container registry, authentication. All the pieces are there, everything you need. You don't have to go become an expert black belt third-party integrator. You don't have to pull from 50 different open source projects and underwrite the risk of doing the integration on your own. It's all done for you and delivered in a package that's very easy to consume and manage. So the platform is built with speed, mobility, agility, elasticity, the ability to flex as demand changes. So you can spin down resources when they're not required. You can bring resources on board and do so very quickly as demand increases. And it's also programmable and composable, guaranteed to ensure platform independence. One of the big concepts that you'll hear a lot within containerization and microservices architectures is this idea of write once, run anywhere. So you don't have to code to specific individual platforms. So you get really a lot of the benefits that you get with virtualization, but at a more code element level. Faster time value and revenue, very flexible, very adaptable, and of course it provides a great integration platform for both existing and next generation technologies as they become available. So,
hey Randy, can I just stop you a second? A few people in the chat are saying that they're seeing the wrong slide.
Oh,
I just want to check.
Okay, yeah.
That everyone is seeing the right slide. I know a few people have said it.
Okay, yeah, right now the slide is transformation is underway is the title.
Which is what I can see.
Okay, good.
Is anybody else not seeing the right slide?
This is the
I think
blessing
just
and
a couple of people have got a glitch. I think most people are on the right one. Sorry. Okay, you can carry on.
No worries. This is the blessing and curse of Zoom, right? In the era of the pandemic. You know, peak times, unfortunately, it gets a little dodgy. I will say, however, and please correct me if I'm wrong, this is being recorded, so certainly the recording will be available as well as the content. So apologies for any edge issues. Great, thank you. So just a little bit more research for those who are perhaps not convinced that the transformation and migration to containers is happening in full force. All of the major analyst houses, you know, Jason came from Gartner, so obviously he spoke about this early on. Enterprises are looking constantly for ways to transform the way they develop and release software and services. They want to be faster, more agile. Containerization is a great new standard for both hybrid multi-cloud deployments and kind of rapid time to market. So, you know, DevOps, 90% of organizations are going through some kind of a DevOps transformation or are in the planning stages. It's typically fairly mature. 90% of enterprises will use multiple cloud services. This is kind of an interesting one and another reason why platforms like OCP are so valuable, because they're designed to support multiple public clouds. And as your organization becomes more integrated into the public cloud, it's very unusual that you'll have a single cloud provider. Most organizations have multiple. There was another study as an addendum to this one, which found that within the Fortune 100, I want to say the number was about 70% reported using 5 or more public clouds as part of their production IT infrastructure. So obviously being able to integrate that many disparate cloud platforms becomes a really important best practice. And application platforms, 60% are considering private cloud and or hybrid cloud as being critical within the next 12 months. And by the way, this survey data is from early in 2020. So clearly this trend has continued unabated. In fact, in many ways, one of the, you know, I don't want to say positive impacts, but one of the impacts of the global pandemic has been a much more aggressive push towards this kind of containerization technology. So one of the things that tends to be or can be an inhibitor to containerization is how you do data management. And the simple reason for that is containers were originally conceived to be stateless. They were designed to be ephemeral objects that, you know, were brought online as needed. They did some work, they processed some information, and then they went away. So they were elastic, they were on demand. So because they were stateless, there was no expectation or design pattern which required that they have data that is persisted from one session or one state to the next. So you didn't have to worry about kind of managing data or managing stated data. So if the container went away and reconstituted, there was never any reference to data that lived outside of that contained entity, that sort of declarative entity. So as containers became more widely adopted in the enterprise, of course, this started to create some real limitations. Enterprise applications are almost always to some degree stateful. They require persistent storage that can survive from period to period, can cross functional boundaries. So persistent volumes and the ability to attach to persistent volumes became very, very critical. Now, this has created a set of challenges around how best to bring these two things together. So this kind of ephemeral design pattern of stateless containers and microservices and the more stateful kind of enterprise-ready storage array. Furthermore, as with traditional workloads, there are still requirements for multiple protocols or multimodal access. There will be workloads that will require block level access. High performance databases are a classic example of this. File access is, of course, very important depending on what sort of a use case, and object is becoming more and more prominent. Now, to further somewhat complicate matters, each of these individual modalities itself requires different container operators and container metaphors and access modes to make it work. So when you factor all this together, the point here is that it's another reason why you want to be very careful about selecting your environment and kind of plot your course wisely as you think about adopting containerization. Now, given that we've talked about some of the challenges, you know, the occasional question we get is, well, why would I want to do this? Given the risk, given the complexity of the integration, why do this? Well, the answer is because you get a huge efficiency and economy of scale by decoupling your infrastructure and making your infrastructure capacity consumable in smaller increments. So you can take an idea and you can, through an efficient agile DevOps process, get to an end service that you can then deploy to your end users and your constituents much faster, much more repeatably, much more reliably, and you can then manage and sustain it similarly in a much more efficient way. So despite the challenges associated with integration and architecture, the benefits far outweigh the risks. So in a hybrid cloud model, you get all of the advantages that come along with containerization of microservices and hybrid multi-cloud architecture, and it will also support your traditional workloads as well. One of the other interesting things that is happening as a result of this trend towards more containerization is it's giving rise to new skill sets. So if you look back even a few years ago, a lot of development was, and has been for some time now, often pushed offshore. So there are organizations, outside the US and all over the world that specialize in doing spec development and creating bespoke applications and workloads based on a set of requirements, which are documented as a collaborative project. As organizations are adopting more of a true open standards-based hybrid multi-cloud architecture, it's creating a need for resources typically in-house that are really less application programmers and business logic programmers and more infrastructure programmers. So they're responsible for provisioning, managing, allocating, sustaining, designing the infrastructure, and then exposing that infrastructure in the form of APIs that can be programmed to and consumed by users and developers. So this is an interesting trend. It's continuing to grow and will continue to grow as hybrid multi-cloud becomes the de facto standard deployment model across the enterprise. So it's both an opportunity and a challenge because people that have this skill set, there aren't a million of them floating around. They're a fairly scarce resource. They're not always easy to find, but it is a skill set that organizations are both seeking and also investing in. So very important. So let's quickly go through some messaging around kind of our philosophy, the IBM Red Hat philosophy on where all this fits and kind of tie it together at the end. So we view enterprise transformation and hybrid cloud as being comprised of cyber resiliency, which is obviously critical to everything we do, advanced data services and operations, which take full advantage of things like automation, machine learning, either at the application workload level or at the infrastructure level. If you look down at the bottom, you'll see a bunch of different infrastructure platforms, both on-prem and cloud, as well as VMs and containers and everything in between. Our goal is to provide a very rich data services layer that sits between your workloads and your infrastructure and provides an open standards-based, single global namespace, very flexible data services layer to support whatever it is you're trying to do. For those who are familiar with IBM's deployment model, we have these things we announced early last year in collaboration with our Red Hat partners called Cloud Paks. They are pre-integrated bundles of software, all based on Red Hat OpenShift Container Platform as the orchestration layer. Now, I won't go into a lot of detail on these. We can certainly have a follow-up, but the Cloud Paks are targeted at different environments. There's a multi-cloud management one. There's one for application development. There's integration. Data is for big data, analytics, and AI workloads. And of course, there is a security-focused one as well, all based on OCP, all providing a common stack integration upward into the control plane. But just as importantly is the ability to do the downward stack integration. In other words, as your environment considers, or your organization considers deploying multiple workloads in a containerized model, having a common set of data services on the back end makes it significantly easier to manage. And this is where a companion technology called Red Hat OpenShift Container Storage comes into play. So just like OpenShift Container Platform provides the orchestration abstraction layer, OCS provides the data services abstraction layer. So here's a few examples, and this is just a sample of different types of workloads. So for example, I'll choose in Cloud Pak for data, we have a lot of organizations that are running ultra high performance, low latency DB2 warehouse solutions. Those DB engine pods, which are running inside OCP, connect via OCS to back-end infrastructure, either a shared file store or block volumes sitting on your existing SAN. So the point here is to kind of take the previous view of the world and make it a little bit more specific. So kind of tie it down. And as we get into Frank's section, he'll give you some more examples of where this plays out specifically on client sites. So again, our philosophy is working together with Red Hat to provide a platform that supports a wide variety of infrastructure. And we're showing some of our solutions. Of course, it works with others as well. A very robust, comprehensive, hardened, enterprise-ready, software-defined storage and software-defined infrastructure portfolio of solutions across scale-out, high-performance block, file, object solutions, cloud services, a very robust virtualization and abstraction layer, whether it be for straight real-time heterogeneous virtualization or backup and archive, and finally, a full suite of management tools integrated into the Cloud Pak architecture you saw earlier, as well as into your current data center environment. So it's a complete end-to-end solution stack with the IBM software-defined Spectrum storage portfolio. Now, this technology is in use, as I mentioned a little while ago, across many organizations, thousands worldwide, across a wide variety of industries and use cases. Some we can name, some we can't. There are very large kind of global 100 organizations that generally don't allow their name to be used publicly. The first one is a large multinational resort chain that is using our software-defined storage solution and our Storewise now flash systems arrays. They have been rebranded, as well as some of our tape technology to achieve a very agile, high-performing, highly scaled platform that does intelligent tiering and ILM that allows them to store hundreds of petabytes of data in the most economical way without sacrificing performance. I talked a minute ago about our Spectrum Scale product. Spectrum Scale is our ultra high performance clustered file system. It is currently being used and this changes from day to day because it's kind of dynamic, but in the top 500 fastest supercomputers in the world, Spectrum Scale runs 11 of the top 20, including the top 2. The point here is that it's hardened, proven, scales exceptionally well, delivers amazing performance. So we also are very keen, working with our partners like Tectrade, to make this technology easy to consume. So you don't have to go, again, do this massive integration. You don't have to put all the pieces of the puzzle together yourself. We have as an offering, and this is just one example, something that we're doing this year, where you can bundle our enterprise leading flash system, in this case, the 5200. You get a base configuration of the 5200, which can deliver up to 460 terabytes of capacity in a single 2U box that comes bundled with OpenShift Container Platform, as well as the storage suite for Cloud Paks, which you saw a few moments ago, and our Spectrum Protect Plus solution for data protection and archive, all in a single bundle with all the entitlements wrapped into it. Very easy to consume, a great sort of plug and play solution to begin your journey towards containers, or perhaps extend an existing container environment. And we're happy to, of course, tell you more about this if there are any specific questions. So at this point, I'm going to take a quick pause and we'll check to see if my compatriot Frank Lee is on, because this is his portion. He and I have been working on this architecture. So Frank, if you're there, I'll turn it over to you.
Andy, can you hear me?
Yes.
Hey, Frank, how you doing? As Clara. So.
Okay. Hi, Frank.
Hey. So good afternoon, good morning. It's good to be here. I'm Frank. I'm the tech sales leader for IBM Storage for Red Hat, OpenShift, and Cloud Pak. So my mission is to help you as a partner to basically paint the picture, but also to engage and help our clients marching on this journey, right? And then if you look at this chart, I'm going to continue on the metaphor here, which is, in addition to farming and animals, we can talk about building houses with plumbings, right? So each one of these platforms that Randy talked about, especially in the middle part, is Cloud Pak that is modernizing the middleware, the data service, the security, the AI. In addition to that, there's also other platform that is also being deployed and certified, validated on OpenShift. So these are the blue color towers, if you will, or houses. So they are DB2, SAP, SAS, right? Even high performance computing software. Some of them are being used for the large banks like Spectrum Computing, are also being modernized to run in this microservice mode using containers. And further to the left, we have these little greenhouse that will be deployed on the edges. Right? So they can be used for inference, maybe driving a camera, or to infuse AI with API, right? On an edge device, could be an ARM server runs in the office, back alley of a McDonald's maybe one day would have that such an edge device. So all these new platform, all these shades of color, they all need the underlying plumbing. We call them plumbing because it's supplying the water to these houses, right? And also not just that, they also need to do the metering. In other words, to manage the data flow, right? To get the data where they need to be. So that's where this data service coming into play. You know, we're representing this using the red color, which is Red Hat container native storage, and the green color, that's the IBM Spectrum storage, like Spectrum Skill or Spectrum Virtualize. I think one of the bundle that Randy just showed you effectively is this little house on the wheel, right? With the plumbing that you can engage the customer with. And then you can deploy this quickly on the edge, in the cloud, or on the enterprise, including that startup kit, right, with a flash system running OpenShift. And then ultimately, I think the goal here is to support industry workloads, to make these data service that I highlighted at the bottom, whether it's ingesting data, tiering data, using policy, synchronized data movements, you know, between different sites to also help with data resiliency, like backup, and also sharing data using different protocol, right? Whether it's the traditional POSIX, NFS, SMB, or the new generation of protocols such as HDFS or Cloud Object Store, S3, right? We can always share this storage tank of water and plumbing to the platforms. And finally, the cataloging, right? So metering. How can we make sure the customer knows where the data are and supply the data where they need it to, right? So, and on top, you can see that in the purple or the dark layer, this is where we map the use case to this online platform. So we're not just building houses for houses, right? We have different use case, we have different sets of industry requirements. Different industry might have different requirements in terms of data gravity, data localization. For example, healthcare has a lot of health data that needs to be localized, whether it's in a hospital or possibly even in a country. The data such as genomics cannot leave, for example, a country, right? If you go to a hospital, the data cannot leave possibly the hospital premise or data center without your consensus, right? So a lot of these are industry challenges, and also we call them architecture decision point, whether it's data and AI or hybrid multi-cloud. So they drive the underlying use case and the workload patterns that we can map our platform into. Okay? So let me take you through a couple of these use cases, just highlight this journey, that it's not just about speeds and feeds and feature and functions. It's also about, can we make ourselves relevant to our customer's journey by understanding the application, their workloads, the workflow, right? And also the business value. Maybe if you can go to the next chart. So the last year is our agile launch for the storage software. And now we're calling this a unified data service. We're combining both Red Hat and IBM capability in terms of the, you can see here, we're representing them in different colors. So the red is the Red Hat, the green is IBM as a data foundation. And then we can stand up a different platform in the green, yellow, and blue color stack, right? In different data center or in the cloud. And then we can use that to support different line of business in the middle. So these are the 9 use cases we have developed or adapted last year. The list actually goes way beyond the 9. These are the top ones. But what I'll do is I'm going to highlight a couple of them that illustrate the problem of number 1, data gravity or centricity. Number 2 is the need for data service, right, to support for example, app modernization, which is probably the most common use case right now, low-hanging fruit. A lot of application moved into containers, like Randy talked about, and they need data service. These data service are no longer the traditional, here's my iSCSI drive, here's my fiber channel SAN, off you go, right? But now the developer are requesting, here's my PVC, persistent volume claim, what can you do for me, right? Can you put a container volume to support my app and my development for a modernizing or refactoring an application? And by the way, I'm doing this on a public cloud, right? Can you support that? Can you also produce a HNDR use case, like from 5 to 8? All these are about data movements, right? It's very easy to say we can build a hybrid cloud or multi-cloud, but without handling the data in the data service, whether it's fully synchronized using HA or asynchronous replication using DR, or in some cases tying up multiple cloud platform, depending on the customer's orientation for certain cloud providers, right? There might be a need to actually build these 3 sites all together. Maybe one site could be on-premise in a customer data center, while the other 2 platforms, one could be running in a public cloud provider, another one could be running another cloud provider, right? So I'll show you a couple. So the first one is, Randy, you can go to the next chart. The first use case is what we call the data and AI. Actually, it's an app modernization. That's an easy one to start with. So think about this, right? So we have a customer. It's actually telco. So we highlight that tower up there. It's called Jazz Cash. It's a new generation telco company from Pakistan. It's actually Pakistan Mobile. So they're modernizing the app digital payment, and by moving to OpenShift and adopting the Cloud Pak for integration for the API interface, and Cloud Pak for data as the sort of the data analytics part of the platform. So their requirements is to be able to deploy this on 3 different platforms, test and dev, which only involves 2 Cloud Pak, production, which they also needs to have other parts like security and multi-cloud manager, and then also some speech-to-text app from Watson AI. And further to the right, you can see they also want a HNDR for the same OpenShift cluster. Okay? Now, in all these 3 implementation, the data service is internal to the OpenShift cluster. It's not external. We're not mounting a volume from a large SAN. Right? Now, the data here is what we call the container native data storage, so which is number 2. So that's provided using OpenShift container storage, mainly the red color from Red Hat. So that actually meet all the requirements to stand up the data service within the OpenShift cluster, right? There's no external storage that's needed. But when they move into production and HADR, now we need to actually put into some commercial grade, high-end storage as a backend. So we're actually using V7000 and a flash system to supply the same OpenShift container storage under the hood. We're also introducing the Spectrum Virtualize using the CSI block driver to supply the data. Right? So as you move from left to right, you can see how we can tune the service to meet the requirements. But at the same time, we can allow the platform to be stood up quickly, agilely, elastically, right? And using public cloud further to the right. So that's the first example of app modernization. The second example, the next chart, is data and AI, right? Very common use case from a customer adopting, developing data science platform. You can see here these different teams working together using what we call the workbench. Right? These workbench are almost like a desktop, but it's a collaborative environment with version control, with all the bells and whistles of GitHub, and also to be able to maintain application containers. Then they all need a backend AI grid to run the jobs, to run these deep learning AI training jobs, to develop the models, right, to do analytics. And then that is backended by a robust scale out data service or data fabric. Right? In this case, it's Spectrum Scale that supply the data IO. So we actually, one of our customers actually call this infinite throughput, because as they can scale up now these yellow workbench using OpenShift and pods and spin up not just dozens of them in the VM world, like using Randy's metaphor here, right? We can have millions of chicken here, these containers running into different workbench. Some of the workbench can be on-premise. Yeah, some of them can actually run on my laptop, right? But they all backended by a robust platform that can scale out quickly to deliver the service, the data service, using the OpenShift CSI driver interface. to feed the compute needs and the data needs. So the next chart talks about the third use case, which is data lake modernization. We have a lot of customer went through a journey of adopting Hadoop as the enterprise analytics and data storage. A lot of these platforms are monolithic. When I say monolithic, they're really tightly coupled, which means you have a very large pool of resource, of which the compute, the storage, the data, the application are all tightly coupled, right? But the new way of doing this is a decoupled way, like Randy talked about earlier. Decouple the compute, the data, the application, right? So now the application can be more easily, quickly, upgraded, modernized. In some cases, moving to some of these Hadoop stack is actually moving to OpenShift as well, right? So you can deploy them quickly, and more importantly, you can scale them out quickly. So if you want to run analytical job using thousands of containers, you can do that quickly, right? In this new architecture. So here you can see with the workbench is moving to Cloud Pak for data, and the underlying storage in the data, and this could be petabytes of data, are moving to a new data lake, right? This new data lake is our unified data service lake, which is Spectrum Scale or Cloud Object Store or Ceph. And you can see how this works, right? So once we decouple this, we can scale the application and analytics and AI quickly. Effectively, the same goal we can accomplish using Hadoop, now we can accomplish in this modern architecture. And at the same time, we will bring enterprise data resiliency, global access, high performance storage, low cost. Right? The goal here is to have 4x the performance comparing to the traditional data lake and half the cost. So the math is just compelling, right? In terms of a business value and return on investment. And I think the next one is the last use case. Maybe I have one more. So this is probably the most challenging one. I call this flying without radar or map, right? So think about a customer trying to deploy all these different platforms, whether it's a research computing, stand up an AI sandbox, which is the second tower, or deploy an enterprise application, or a enterprise data catalog, right? These are actually 4 vertical platform or houses a customer trying to build, and they have lots of data under the hood, right? Whether it's in Spectrum Scale, that's number 3, or in the Red Hat Ceph, or in a Cloud Object Store, number 5. How do they know where the data are, right? So the cloud platform doesn't solve that problem. The cloud platform gives you the yellow and the blue that allow you to spin the thing, spin up a platform quickly, deploy them, right? The data is still in the tank. It is still in the storage tank, right? Without opening the lid, you can't see them. The way to handle this is not the traditional way, right? Continue to build more silos. In other words, you have now in addition to your Hadoop silo or data lake, now I'm going to create another platform I'm going to call it, Kubernetes or OpenShift. That's just going to be my new project, right? Shiny toys. So I think if we do this right, the new architecture in the unified data service would not create new silos anymore, right? Because we cannot decompose the data service, will supply the data, and will provide you with a metering capability or the maps or the radar, right? So that's number 6. So whether you have enterprise data lake, that's number 3, or you have the new Cloud Object Store from IBM, which is number 5, or Red Hat, which is number 4, right? We will provide you with an enterprise data catalog based on an IBM storage software called Spectrum Discover. Give you insight, knowledge, and follow them, keep up with data change, right? And then supply that knowledge or insight into the cloud platform. So now when you're doing your AI or enterprise deployment, you can find the data. You can assemble data sets. We just did a webinar this morning, encourage you to look into it. For the new version of Discover, we can actually trigger more action like data movements, right? From cloud to to on-premise or back. So this is a very compelling use case. What I call if the first 3 use cases is about data volume and gravity, this is really about the value we can bring, because we no longer just a bunch of disk with wires sticking out, right? We're software. We're now also the insight of the data. Another metaphor I can make here is think about a library without catalog, or even worse, a library without shelving. All the books are piling on the floor, right? So IBM storage software give library the shelves where the data, which are the books, can be stored, and Spectrum Discover provides a catalog that a reader or librarian can search all the content without piling through the or digging through the shelves, right? So I'm gonna end here. Hopefully these are inspiring use case for you. By the way, they are all real customer engagements. Some of them are still ongoing projects as we're working with our clients to sort of figure things out, put them into deployment. The goal here is make them real, make real impact, deliver the value to the clients to show that the new cloud way, not only we can scale and bring a lot of houses up and kitchen and chickens and to the farm, but we can solve real world problem, right? To support these different industries, different workloads. So Randy, I think that's it for me.
Yeah, awesome, Frank. Thanks very much. Great. So we've covered. Let's see, we've got farm animals, housing construction, library books. I think we've covered all the analogies. So this is perfect. Thank you very much, Frank.
Oh,
so
sure.
and just a quick editorial comment. Frank is being modest. It's not hyperbolic to say that he is one of the world's foremost experts on data services architecture for containerization. He works with our largest global clients. So he is a deep domain subject matter expert here, and we're glad to have him. So some quick takeaways from the session today, which hopefully you'll walk away with. Hybrid cloud, hybrid multi-cloud is happening now. It is the future. It is the present and the future. It is the evolving architectural standard that's being adopted pretty much by every organization, just about across almost every industry around the world. And containers are really the common language and the lingua franca of hybrid multi-cloud. So if you're thinking about moving into that environment, that almost implies containerization. Containerization is the language spoken there. It's the vehicle by which those become real. You definitely need a strong data persistence, data management, data services, and storage foundation. It is sometimes tempting. I mentioned a few different times that there are a lot of opportunities to do your own integration work, take advantage of open source projects and software and, try to do your own piecemeal assembly, which is certainly possible and companies do it. It's risky. It tends to be much more time consuming than you suspect. And it creates a lot of vulnerability for production, reliable production workloads. So our storage solutions for Red Hat OpenShift Container Platform, we believe are the best in the industry. We're probably biased since we own Red Hat, but I think our customers, and Frank has given you some examples, I think our customers by and large would agree. We've had great success with the solution in the marketplace, and we hope to continue growing the footprint and again, working with great partners like Tectrade that have the in-house expertise and domain expertise to architect these solutions on your behalf. And finally, containers are like chickens. So if you don't remember anything else, just remember that containers are like chickens. So that brings us to the end. I want to thank everyone for your attention. Much appreciated. I wasn't able to monitor the chat, the QA, so we have some time left now for questions. We can certainly open the floor up to that. I want to thank Tectrade again for inviting us to join you today. The QR code here is all my contact information. If you want to snap it, you'll have my virtual business card. But if there's any questions, we're happy to entertain them now. So I don't know, Claire or anyone from the Tectrade side, anything we can address that maybe wasn't already covered?
No, I think that was great. Thank you so much, Randy, Frank, Jason. Appreciate everybody's time that's joined the webinar. There will be a little pop-up questionnaire that will come at the end of the webinar when you close. So if you could just respond to that. Otherwise, if you would like to have a one-to-one session with any of the experts that we've had on today to get into some of the details around your specific workloads, we'd be happy to arrange that. But hopefully this was an informative session for everyone, and we really appreciate your time.
Yes, thank you very much. And again, apologies for the minor technical issues. Hopefully, if you had issues during the broadcast, you're able to check out the recording and or the content. And again, as Claire mentioned, we're all available to have further discussions if needed. So thanks again.
And just from the Tectrade side, I personally would like to thank Randy, Frank, and John for all of the input to make this such a successful session. Thank you very much on behalf of Tectrade.
Thanks for having us, Jason.
Yes, thank you. Okay, so I guess we will wrap it there. We'll give everyone 5 minutes of time back, which is a valuable thing. Again, thank you for attending. Thank you for your questions and your engagement, and hopefully we will meet again. Thank you.